champ, how are you doing? Welcome into another amazing session, champ. And I'm your master teacher, Shivam Gupta. So in today's amazing class, we're going to see that how we can apply the basic proportionality theorem in different kind of question. So champ, today's class is going to be very important class to make sure you're writing every concept and every theorem and every question also. So let's get start, champ. So in this class, we will take the use of BPT in the trapezium, in the intercept theorem, and improving the equal intercept theorem also. So let's get start with the trapezium. So then we know that the diagonals of the trapezium divides each other in the same proportion. But how can we prove it? So then in order to prove this, we have to draw one line through the point of intersection of both the diagonals, and that line will be parallel to the lines or sides of the trapezium also. So we can see that the line XY, which is passing through the point of intersection of both the diagonals, is parallel to PQ and parallel to SR. Now in order to apply BPT, we have to consider those triangles where one side of a triangle and the XO are there. So in the first one, we can consider the triangle PSQ, where PQ is parallel to XO, so that we can apply BPT. So now, champ, from BPT we can say that PX upon XS is equal to OQ upon OS. Yes, same. We have to consider one more triangle. And why so? Because till now we got this ratio. Now we want this PO and OR. So we can say, champ, PO and OR is coming inside the triangle PSR. So if we will consider the triangle PSR, we can apply the BPT. So we will be getting PX upon XX is equal to PO upon OR. Now, champ, from equation 1 and equation 2, if we will equal both the equation, so I will be getting QO upon OS equal to PO upon OR, and hence we have proved that diagonal of the trapezium divides each other in the same proportion. I hope it is clear. Very good. Now, champ, one question to think about. That let's say this condition is given, that the ratio of the diagonals are equal, then can we say the sides will be parallel? Let's figure it out. So, champ, let's prove this with the help of BPT also. So let's say it is given the diagonals are getting intersected, are getting divided in the same proportion, and we have to prove that PQ and SR are parallel. That means they are trapezium. So now, champ, after drawing the XY, let's consider some triangles over here. In the triangle PSR, XO is parallel to SR. So we can apply BPT over here. Yes. So I can write PX upon XX is equal to PO upon OR. Now, champ, from the equation 1 and equation 2, PO upon OR is common. So we can say that QO upon OS and PX upon XX are also equal. If they are equal to each other, that means the line XO and PQ are parallel. Yes. That means the line XY is also parallel to PQ. Yes. So we can say that PQ is parallel to SR also, because in the starting we have constructed a line which is parallel to SR, and hence if a quadrilateral where two sides, opposite sides are parallel, it's a trapezium. Hence we have proved it. I hope it is clear. Very good. Now, champ, let's see how we can use BPT in order to prove the intercept theorem. So, champ, if we have three lines or more than three lines which are parallel to each other, and let's say we have two or more than two transversal lines which are intersecting them, then, champ, the ratio of intercept, that means AB upon BC, will be equal to PQ upon QR. So now, champ, let's see how we can prove this. So let's say we have these three lines which are parallel and two transversal lines. If three lines are parallel, that means we can use the BPT. In order to use BPT, we need a triangle. So now, champ, in order to get a triangle, let's join the point A and R so that we can get the two triangles. Now in the triangle ACR, BO is parallel to CR. Yes. So we can apply BPT over here. We can write AB upon BC equal to AO upon OR. Same champ in the second triangle APR, OQ is parallel to AP. So we can apply BPT over here, right? We can write that PQ upon QR equal to AO upon OR. Now champ, in both the equation, AO upon OR is the common ratio. So with the help of that, we can write that AB upon BC equal to PQ upon QR. Hence proved. Now champ, the question comes that what if AB and BC, both the intercepts are equal, right? So let's figure it out. So now champ, let's say if AB and BC are equal intercept, that means we can say that it is equal to 1. And from there, we can say that PQ is equal to QR, right champ? So now how we can prove that PQ is equal to QR? So now champ, in order to prove this, if AB equal to BC, then PQ equal to QR, the same theorem we can apply, the intercept theorem, that if 3 or more than 3 lines are parallel to each other, then the transversal line intersect them. Then champ, the ratio of the intercept by both the transversal line are equal, and from there we can prove this also. So now champ, let's summarize our class. So in this class, we have seen some very important application of BPT. The first one, that in the trapezium, the diagonals bisect each other in the same proportion. And how did we prove this? With the help of some construction, we construct a line passing through O, which is also parallel to PQ and SR. Then we took two triangles, one is PSR and one is PQS. In both the triangle, we applied BPT and we got the result. After that champ, we have seen the intercept theorem also, that the ratio of intercepts formed by the transversal on 3 or more than 3 parallel lines is equal to the ratio of intercept formed by each transversal line. That means we can say that if L1, L2, L3 are the parallel line and T1 and T2 are transversal line, then T1 is intersecting at ABC and T2 is intersecting at PQR. Then AB upon BC, the ratio of intercept formed by the T1 transversal line is equal to the PQ upon QR, the ratio of the intercept formed by the T2 transversal line. And then we have seen that if both the intercept AB and BC are equal, then PQ and QR also be equal, champ. I hope it is clear to you. Now champ, don't forget to practice. Stay tuned and keep smiling. Bye-bye.